Thank you. We have B612 hold.
Hello, can you hear me? You cut out for a second.
We hear you.
Loud and clear.
All right, great. Thank you very much. My name is Ed Liu. The product that we're developing is called Space Map. It is the first comprehensive map of the solar system, and I'll tell you why that's important. Next slide, please. Just like everywhere on Earth, the mapping of new territory, of new frontiers has been the key to opening up economic development for defense and for science. And the same thing will be true of the solar system as it was here on Earth historically. You know, you've seen this story happen over and over, everywhere from the great ages of exploration to the opening up of the US frontier to even things like frontiers of genetics in which the mapping of the genome was the key to opening that up. It turns out that 99% of the objects in space are currently untracked, unmapped in our own solar system. Next slide, please. What our aim is to do is to take the data that is going to be coming in from large telescopes and will be publicly available on these objects in space, the locations, the trajectories, the exact uncertainties, and so on, and make something usable. We want to make space navigation, in the end, as easy as using Google Maps on Earth. You may scoff at that at first if you think about saying, well, how could that be easy? It turns out that that was the exact same story in 1990 as Google Earth was beginning, in which at the time it was a private company before it was acquired by Google. But this whole idea that anybody could do geospatial mapping and coordinate system transformations and things like that are common on Google Earth or Google Maps today, without being a trained CIA analyst, people scoffed at that until it became real and it became obvious. And now middle school students can go ahead and do the things that trained analysts did in 1990. That same trajectory is going to happen in space. So what we're doing is we've got an initial funding. We're a very early company. We just have a tiny amount of revenue right now. We're just starting up. But we have some of the biggest partners in the game here that are partnering with us. Go to the next slide, please. Who we are, I'm Ed Liu, former NASA astronaut, also worked on Google Maps. And we've got a number of other folks who are some of the leaders in the field. Probably Hank, John, Alan on the astrodynamics side. That is astrodynamics being the calculation of trajectories in space. Three of the leaders in the world. And then on the software side, as this really is a software project, we have Carice Fernandez, formerly out of Google, also another refugee from Google besides myself, and Kathleen Kiker, formerly out of Lockheed Martin. Next. So what is the so that's the vision of the company, where we're going with this, and the value of the company is going to scale with the value of both commerce, science, and operations in space, which is, as you know, growing very, very fast. And historically, it's been growing at a rate of about 10% per year over the last 3 decades. Doesn't sound like a lot, but the power of compound interest, that means that the economy of space within a few decades is actually going to be larger than that of many small countries currently. And that's the bet that everyone's placing. That's why space is so hot right now. Our first product is this mapping system, again, sort of Google Earth or space. And what it really is a platform that allows you to do trajectory calculations, location-based calculations at scale easily. And it's the same process that we did at Google Earth, which is taking the algorithms, which are known and are actually open source in many cases, and making them just work. There are thousands of algorithms, thousands of coordinate systems, things like that need to be plugged together. And currently, none of it works easily, and it literally takes a PhD some number of years to do even a single calculation. We need to make that such that that happens, and the connection to the data sets happens within seconds. Next slide, please. So who are our first customers? And well, the current situation is that as I mentioned, the things are difficult to use today, and the current people who use these are generally people who work on space mission operations, and we want to make their jobs much easier. So our first set of target customers is, in fact, these people working on space mission development, planning, operations. So it turns out that there are, at the moment, that's number of companies doing that and researchers doing that is in the many hundreds, and growing fast. And what do they do today? Well, they use commercial software. They hire teams that are expensive. Um, they hire navigation teams, operations teams, and so on. The typical software that they use, of which it generally takes a PhD to run, um, runs at about $250,000 per seat license. So that's our competition at the moment. And we think we can do that much better. So our idea is to provide this as a service, on a SaaS platform that just works. So next slide. As I mentioned before, our target operators, we believe, have in the near term, an addressable market. It doesn't sound that large, $50 million, but I think we can come to dominate that, simply by being easier to use. Now,
Hey, Ed, we should start wrapping up.
okay. Again, the long-term addressable market is, I think, that's the real goal here. As operations in space continue to increase, the need for these types of things is going to become apparent for a lot more people than just the specialists. It's the same story that we saw in Earth geospatial mapping. Next slide. So where we are right now, we are not raising at the moment, but thinking about this in the bit, we are planning to raise in the next few months. So what we are doing right now is we're looking for the right set of investors who understand the vision, the long-term vision, that understand that this isn't just a short-term play to help spacecraft operators, because that's not a very large market, truthfully. But that we're looking for the type of investors who can think about this over the decades-long process it's going to be, but realizing that there is a short-term goal, a short-term product that does meet a current product need that we think can help fund this thing along. Thank you very much.
Any questions from our panel?
I have just with one quick question. I don't understand that there's much time here, but and I think your technology, I mean, your solution is the right time and right kind at this point. But do you have any thoughts on how you're going to approach and work closely with government programs? I happen to know a couple of programs there that your solution might fit well, but I was wondering what kind of effort you've made.
Well, we were talking to a number of the government programs. So the folks that would use such a thing are in everywhere from Department of Defense to NASA to NOAA, which is the National Oceanographic Atmospheric Administration that operates satellites. A lot of them have homegrown solutions currently. A lot of them do use commercial software currently. Nearly none of them is satisfied with what they've got right now.
Right. Okay. All right. Thank you.
I have a quick question.
Some government funding.
Sorry,
Go ahead.
Ed. I was wondering, what are the proprietary aspects of what you're specifically doing?
The astrodynamics algorithms are things that you can look up in textbooks, but just like, again, I keep coming back to Google Earth or Google Maps because that was my experience. What made it so usable and so valuable is the fact that somebody built a cloud-based system that made all these things just work together. So in order to build the system, you have to have a knowledge of astrodynamics, you have to have B, a knowledge of cloud computing and how to build systems. and C, you need to know how space operations work. So if you don't have all three, you really can't do this. And I think we do.
Fantastic. Thank you, Ed, B612.